Good morning, everybody. This is Dingaan Mahlangu again. I'm back with the last part of our session, which is the third session on proving the Pythagorean Theorem. So I'm still using Blender, and this is purely for entertainment purposes. So it has got no technical background of any kind. It's just for those who want to learn nodes, geometry nodes, and also just curiosity for the Pythagorean theorem. So I just wanted to show you, last time I did the text that you could see the length of each one of them. So what I've done is I've created a group because I don't want my viewport to be too clumsy, lots of nodes. So I just created this group node, which inside is just for how you can allow the text to be put in any of the either X, Y, or Z a length that we are working on. So if I click there and I click tab, you can see inside the nodes that I've used the curve length, which just determine the length of the line here. In this case is the R, and then you can see then what I did is I just took the value and made it a string. This is the value that appears here, and then from there I took the string, made it a curve, filled the curve so that it can look filled. Actually, if I can show you under I can just see you, this is the curve when it's filled. So you can see that inside it has got that fill. So if it didn't have a fill, you wouldn't see the inside. What I'm trying to say now is that if I go there and open it again, if I can just go straight without filling the curve and come straight to the geometry, you will see it's got a gap there. So it's not filled. So, but if I fill it, I take it back again, click tab, and I make sure that this one is part of that, then it fills it inside, and then I set the position because I wanted to determine where it must be. But in order for me to always make sure that the position always stays at the center, I used this node here, which just samples the curve. So I made it halfway, that's where that 0.5 comes from. So I'm making it halfway, but in order for me to always make it part of changing it there, I have put it under the group input, that side, and then it displays on the group output on the other side. So I just wanted to show you, and I've done it for both, for all three, for the X, the Y, and the Z, so you can see the values. But the nice thing is that as you change the value, it also changes the size of the text. So if I come here, let me change, say I'm changing my Y, I'm making it smaller, the size of this text also keeps getting smaller. When I make it bigger, it also keeps getting bigger, which is the idea of for visibility purpose, so that you can always see it when it's big, but also when it's small, it does not get to occupy the whole area and you don't see anything anymore. So that was just that. So you can see that I've just now grouped it. If you want to group any of the nodes together, you just use Control G, then you create a group. And then also you can label it with using F2. You can label a particular group, but you can also label this icon of the group. And then if you want to label the icon of the group, you just right click and you say rename, and then you can name the icon of the group. So that is it up to that far. But in this third lesson, we just want to now prove that the x squared plus y squared is equals to r squared. That is the main purpose of this lesson. So all I've done is I've just made it easy to just switch showing the number and not showing it. You can see all the numbers, or you can remove all of them in one go and you don't see them. So I just used the switch note, so you can put the switch and connect it to the group input so that you can directly use it under the modifier, the geometry modifier. So now I'm going to go straight to the proof. Now the first thing I want to do, I want to show you now the area, this area here, because this is half x times y, but we are saying we want to look at x plus y, because we are saying x squared plus y squared is equals to r squared. So if I show you these areas, this is x plus y squared. So this white area is x plus y squared, because x plus y, this is x, this is y, because that is the same as that those two lengths are the same. I just took this y and I've put it there. So that is the easiest way of trying to explain it, to explain x plus y. So now if I go further now, I just want to talk about the equation itself. Let me press N to make it easily. So we are saying x squared plus y squared is equal to r squared. We are not saying x plus y all squared. So what you're seeing here is x plus y all squared. So this white area is x plus y all squared. But the equation, the Pythagorean equation, says x squared plus y squared is equals to r squared. So what is x plus y all squared? When you expand this, it's going to be x squared plus 2xy plus y squared. Meaning that now we don't have just x squared plus y squared. We are having an extra 2xy. And now if I can just show you, I'm going to just disable the middle here so that you can just see. Just remember that this is x plus y all squared. So what is 2xy? So what is xy in the first place? If you look at xy, xy is x times y, meaning that is two of these triangles. To put it easy for you to understand, I can just bring it closer here. Look there. This, the first part, this is x, y. So it's x times y. It's two of the triangles. And then 2xy is just double this, meaning it's taking also those ones. All four triangles together forms 2xy. If you bring them together like this, you will form 2xy. So this is the 2xy. So 2xy is this white area here now. So now if I go back again and just have it original, now we understand that the white part is 2xy. So if I subtract 2xy from x plus y all squared, if I can subtract this, it will mean I'm removing the white part. I'll be left with the red part. My apology. I'll be left with the red part. So now if I'm left with only the red part, it means I'm left with r squared, because this red is our r squared. Therefore, that will imply that x squared plus y squared is equals to r squared, because it is less 2xy, and 2xy is the white part. So that is just as simple as that on how we can prove the Pythagorean theorem. I hope This is short and simple, but it makes a lot of sense to all of you guys. I hope you've enjoyed my 3 sessions of the 3 videos. I'm hoping to see you on other lessons just for entertainment also. Thank you.